Hello everyone, welcome back to my YouTube channel SummarizedAI. As part of today's video, we are going to build a stateful chatbot using LangGraph and SQLite. Wait, before we talk about chatbot, first let's try to understand SQLite in detail. SQLite allows us to store and retrieve data. In our case, it is going to be conversation history, what we are going to store in SQLite. It will remember past messages even after restart our application. Now, what is SQLite in actual? SQLite is not a server like MySQL or PostgreSQL. It is a lightweight, file-based, embedded relational database that stores data in a single file having extension as .db. It requires no server setup and no extra installation. It is commonly used for local storage, prototyping, and embedded application. If you see on my screen, we create this DB something like this at runtime, and it remains there. If we restart our application will read the file. Python by default includes SQLite as a standard library. This module is a wrapper around the SQLite 3 library, which is bundled with Python itself. When you install the Python, you automatically get SQLite engine, SQLite 3 library, Python bindings with SQLite 3, which means SQLite runs inside your application. Now, let's try to understand the whole process. When you write connection equal to SQLite3.connect message.db, here Python loads the built-in SQLite engine. Check for message.db file exists or not. If file exists, it open file for us. If file doesn't exist, it creates the file. Now, message.db file, it contains tables, rows, indexes, schema, and data. Now, if you talk about this perform operation step, it will perform read-write operations and stores data directly in the file. Finally, return response back to Python. Now, this is the right time to discuss our stateful chatbot use case we are going to implement using LangGraph with SQLite for persistent memory. When the application starts, it initializes the SQLite database, for example, practice.db here, and creates or open messages table to store messages and assistant conversations. Now, this assistant conversations is nothing but the response from LLM. Once user enters a message, LangGraph executes a defined workflow. It first loads all past messages from SQLite and converts them into LangChain from message object and append the current user input. This full conversation context is then sent to an OpenAI chat model, and chat model generates a response with the help of OpenAI. Now, both the user message and the AI response are saved back into the SQLite database, and the final response returned to the end user. This cycle repeats for every user input, allowing the chatbot to remember previous conversations across runs without requiring any external database server. It will go to the user input and then load all the latest messages from the SQLite database. Then again, it will combine the message and the user input, the earlier messages and the user input, send it to the OpenAI and then get the response. Now we save or store that user input and OpenAI response again in the SQLite DB. This process continues until and unless user types exit. Once user types exit, the program execution gets stopped. And whatever database or DB file we have created, that file persists that data. Now, again, if you're starting your application again, it will have that data available. And if user is providing any input, then it will load that earlier data also. And this particular process continues. Now let's go to our Visual Studio and see the implementation. Now let's first create a Python file and say chatbot.py. Okay. And before we start our implementation, we require some of the libraries to be available in our local. And what are those libraries? The very first library, what we require is LangChain. Okay. And the second library, what we require here is LangChain underscore OpenAI. And the third one is LangGraph. Now, what we can do, we can go to our command prompt or in our IDE's terminal, we can copy paste these commands and install the respective libraries. So let me go ahead and copy paste these commands one by one. Now, if you see, I'm getting one message here in my terminal, requirement already satisfied, which means I'm already having these libraries installed in my local. So you may or may not be getting this message depending upon you are having this library in your local or not. Great. Now we have the libraries available and we can go ahead and start our implementation. So the very first thing what we require here to import SQLite 3, okay, because we are going to use SQLite. So import SQLite 3, and after this we are going to use typed dictionary and list from typing. So we can say from typing, import typed dictionary, comma, list. Great. Now, after this, we require the messages. So we are going to use human message and the AI message for the prompt. Okay. And that we are going to get from langchain dot messages. Import human message, comma, AI message. Great. Now we require OpenAI also. So for that, we are going to say LangChain underscore OpenAI. Import chat OpenAI. Now, after this, the last one what we require here is LangGraph. So we can say from LangGraph dot graph, because from LangGraph dot graph, we are going to use state graph. And state graph will help us to create a graph which is going to have the nodes and the edges. Great. So let's do that. We can say here import and then state graph. Now, because we are going to use the state graph, we require to have the start and the end state. So for that, we are going to import start and end. Now, as we are going to use this SQLite, so for that, we require one database name. So the database name, what we are going to have here is practice.db. Okay. Now, the very first thing what we are going to do, we are going to write a function for just to create the database and the table. And the table name we are going to use the messages. So let's do that. Define init underscore db. Great. Now here you can simply say connection equals to SQLite 3 dot connect. Okay. Now inside this, you just pass database name. Okay. And as soon as you write this line, it will allow you to create one database file parallel to chatbot.py, under which we are going to create our tables and other schemas. Good. Now, once we have the connection, we can simply get the cursor. So here we can say connection dot cursor. Okay. Now, after this, we can say cursor dot execute. Now, inside execute, we can write our query. So let's do that. So here we can simply say create table if not exist. Okay, and you can just provide the table name as messages. So inside these brackets, let's define our columns. So the very first column we are going to have is the ID, and ID is going to be a type of integer, which will be our primary key, and this is going to be auto increment. Okay. Now after this, we require to have one more field, or I would say column, which is role, and role is going to be a type of text. Now after role, we require to have content, which is also going to be a type of text. Great. Now, once we executed our query, we have to commit those changes. So after this, we have to write connection dot commit. If we don't write this particular statement, our messages table will not get created. Good. Now, once we commit our changes, we have to close the connection. Great. Now, let's try to run this particular method first. Okay. And this method will allow us to create the database and the table. So let's do that. Close this and just run this piece of code. And you would see here one file will get create practice.db. So you can see our code finally got executed, and this is the file practice.db got created. Now, if I go inside this file, you would see something like this here. Okay. Now we are going to write our data into this particular database inside the messages table. Good. Now let's close all this. Now we have a code to initialize the database. Now what we require is to save data. So as discussed earlier, we are going to save the messages and the user input as part of our messages table. So let's do that. So we can say here define save underscore message. Okay. And it requires two things, So the very first thing we require is the role and the content. So let's pass that. So role, which is going to be a type of string. And similar to this, we have content, which is also going to be a type of string. Great. Now the same thing again we require here is to create the connection. Okay. So connection equal to SQLite3 dot connect and pass the database name here. Now, similar to this, we require to have the cursor here, cursor equal to connection dot cursor, okay, execute one query. So cursor dot execute, okay. Now inside this execute, we are going to write our insert query, which will allow us to insert the data in the table. So we can say insert into messages, role, comma, content, column name, and then you can say values. Now values, we are expecting two values, so two question marks, and just provide the variable names, role, comma, content. Great. Now, once the insert is done, we require two things to save the changes. The very first thing is connection dot commit, okay? And the second thing what we require here is connection dot close. Great. Now this will allow us to save the changes in the table. Now the next function, what we require here is to load the messages. Okay. And for that, let's create one more function. So let's say define and load underscore messages. Why? Because we are going to load all the messages from the table. So here you can say the same thing again. So connection equals to SQLite3 dot connect and just pass the DB name. And after this, we require to have cursor and cursor equals to connection dot cursor. Okay. Now, after this, we have to execute this cursor. So we can say cursor dot execute and pass your query here. So you can say select role, comma, content from messages. Okay. Now, as soon as you write this, it will return all the rows from the table. So now here you can say rows equals to cursor dot fetch. Now, if you say fetch all, it will allow you to fetch all the rows from the table. And if you say fetch one, it will give only one row. So we require all the rows. So we are saying cursor dot fetch all. So it will give the complete data. So now here, once we have the data with us, we can simply say connection dot close. So here we are not saying connection dot commit because we did not make any changes to our table or the database. So we don't want to commit anything. We are just reading. We are just performing the read operation. That's where we don't require that commit. Now, what we can do here, we can convert all our rows into messages, which is going to be a type of human message or the AI message. So let's do that. So here you can say for role, comma, content in rows. Okay, press enter. And you can say here if role equals to user, then what you're gonna do, you are gonna say messages dot append, and then you are going to get the human message. And just simply content equals to content. Okay, so we have converted this particular message into human message. Okay, and then we saved it into messages. Good. Now, if the role is not user, then you can have one else statement. And inside this else statement, you can again write messages dot append, and here you can say AI message. And inside this AI message, you can simply say content equal to content again. Great. So if the role is user, make it a human message. If the role is not user, then you make it as AI message. Now, once we have all the messages with us, we can simply return those messages. So let's do that. Great. Now, up till here, we have created three functions for create, write, and read operations. Good. Now, after this, what we require here, because we have already imported this chat OpenAI, so we are going to create the LLM model. That LLM model we will be invoking later. LLM equals to chat OpenAI, and inside this chat OpenAI, you can write your model name. So the model which we are going to use here is GPT-4o mini. Okay. Great. Now after this, we require to have the API key. So for API key, I have already created a video. You can go ahead and check that video to create this easily. I am having this API key available with me. I am going to go ahead and copy paste it here. Great. Now we have this LLM model. Okay. We will be invoking this particular LLM later. Now, before we start our implementation with the graph, we require to have the shared state. And shared state is nothing but from where our nodes will read or write their output so that other node can access that data and perform operation. So let's create that. So class chat state, and inside this chat state is pass typed dictionary. Now here we require only two things. The very first thing is the user input, which is going to be a type of string. And the second one is nothing but the messages, which is going to be a type of list. Great. Why list? Because database or the messages table is going to return the multiple rows, and every row is an item for this particular list. So as you know, we are going to use graphs, and in graph, we are going to have nodes, and nodes are nothing but functions. So those functions or the nodes we will require. So we are going to create three functions as our nodes. The very first function is a load history. So it will load the rows from the database, 100% of the rows. And the second function, what we are going to create here is chat node, which will allow us to invoke the LLM and pass our messages and get the response from OpenAI. And the third function, what we require is to save our human and the AI messages with role in our database. Great. So let's do that. So let's define a method, define load underscore history. Okay. And it will require a state, which is chat state. And this method will allow us to load all the messages from the database. So here we can say history equals to load underscore message. Okay, great. Now, once we have this message with us, what we can do, we can return all these messages. So here you just simply say messages and just pass this history. Okay, and the latest user input in the form of human message. So human message, and then inside this you can simply say content equals to state, and state is nothing but the user input. So now you have all the messages. So whatever messages you are having in your table and the current message what user has just typed. Great. Now after this load history, we require to have a chat node, which will allow us to invoke the LLM. So we can say define chat underscore node, and again we require the state here, which is nothing but our chat state. Great. Now inside this, let's say response equals to LLM dot invoke. Okay. And inside this LLM dot invoke, we are just going to pass all the messages from the state. Okay. So because we have saved all of our messages in the messages shared state. Okay. So we are accessing this here. Return final messages. Great. So here you can say messages. Excellent. And here just pass the messages, all the earlier messages, whatever you are having, and concatenate the current response. Okay. We cannot pass this directly as a string. Okay. So we require a list because this particular message is expecting a list. Great. Now, after this, we require to have a function which will allow us to save the data into our database. So we can say here define save underscore to underscore DB. Now inside it, you just provide state as chat state. Great. Now let's access the message. So last underscore user. Okay, you can say here state and then simply the messages and the -2. So if you say -2, which means you are extracting the last element. So first from right in our list. Now here you can say last AI. Here you can say state. Then again messages and just say -1. Great. So you will get the AI message. Now we have to save both these messages in our database. And for that, we can call this particular save message function which we wrote here, it will allow us to save the role and the content to our database. Let's do that. So here you just say save message and just say user, comma, you can simply say last user dot content. And similar to this, you require one for the assistant also. Great. Now here you just provide last AI dot content. Excellent. And now just return the state. Great. Now we have all the nodes available with us. Now what we require here to plot all these nodes on our graph. So for that, we are going to use our state graph to create that actual graph having nodes and edges. Let's do that. So we can say here graph equals to state graph and pass the state as chat state. Okay. Now, as our graph ready, we can define our nodes. So let's convert these functions into node. So you can say graph dot add node. Okay. And here you can simply say load underscore history. So you can say load history. Now, after this, we are going to say graph dot add node. And here we require to have chat, and which is nothing but our chat node. Now, the last one, what we require here is save. Okay, which will allow us to save the data into the database. So you can simply say save to DB. Great. Now we have all our nodes available. Okay, but what we require here is to create the connection or the edges in between the nodes. Let's do that. So here we can say graph dot add edge, and the very first node what we require here is the start. Okay, now from the start node it will go to the load history node. Okay, great. Now after this you can again say graph dot add edge, and from load history, okay, from load history it will go to the chat. Great. Now after chat it will go from chat to save. Great. Now once the data is saved, it can go to and. So here we can say graph dot add edge, and from save it will go to and. Now once we have the nodes and the edges available, we can go ahead and compile our graph. So we can say chatbot equals to graph dot compile. Okay, and you can simply write here print and just say SQLite plus LangGraph chatbot. Okay, and just say type exit to quit. Great, this is done. And here you can say escape character as /n. Great. Now after this, as we are going to create the chatbot, which means we are going to provide or enter multiple messages or the queries. Until and unless we don't type exit, our flow or the program execution should not get stopped or terminate. So for that, we can use a while loop, okay, and which is going to be always true. And let's take the user input first. So you can say user input equal to input and just say u colon. Great. Now we can simply say if user input dot lower equals to exit, then what you have to do, you have to simply break the flow. Great. Now if user don't type exit, this means we have to continue, and for that we are going to say result equals to chatbot dot invoke. Okay, and just provide the user input here. So here you can say user underscore input and then colon user underscore input. Great. Now, once you have this, you are going to get your response back as part of this result. So here you can simply say result in the bracket, we are expecting the messages and as -1 and store this into AI underscore message equals to. Great. Now, finally, you can print your output. So you can say bot and just simply say AI underscore message dot content. Great. Now, what I'm going to do here is I'm first going to execute this piece of code and then we will try to understand how this flow is working. Great. So let's execute this. We can see the output here, SQLite plus LangGraph chatbot, type exit to wait. Great. So here I'm going to say just hi, and it will provide the response to us as hello, how can I assist you today? Okay, we can type one more query and we can say what is Python? Okay, and it will again provide us the response. Yes, we got the response. Then again, it is asking you one more query. So you can say simply exit here. And as soon as you type exit, the program will get terminate. Now, how this thing works? So the execution gets start from here. As soon as you type chatbot dot invoke, okay, this is nothing but our start step, okay, and whatever values, key value pair we are providing inside this invoke, okay, as a dictionary here, all will get saved as part of the shared state, okay. So which means after this it will go here. Okay. So we already ran start, which is nothing but invoke. Now from invoke, it will go to the load history. Okay. Because this is the flow. It has to go to load history from start and then from load history to chat and chat to save and save to end. So once it will go to the load history is nothing but our load history method. So let's go there. So this load history method is calling load messages. And this load message is nothing, but it is reading the messages table and getting all the rows and converting all the rows into the messages and returning it as a human message and AI message list. Now, after this, it will call the chat. Chat is nothing but chat node. This chat node will invoke the LLM, which is nothing but our OpenAI GPT 4 mini model. Okay. And here we are passing all our messages, all our human messages and the AI messages, and it will provide us the response. So all those messages and the response we just got, we are saving that back into the messages. This is what chat node is doing for us. Now, after this, we are calling a save method. And if you go to the save node is calling save to database. Now, the save to database method is extracting the last user message and the AI message. And both the things we are again saving back into the database. Okay. And just return the updated state. Great. And the execution will get complete here for that particular flow. Okay. Now it will go to end because we have written the true here. It will again go ahead and get stuck here. Okay. Then it will again ask input from you. If you provide anything apart from exit, it will again go here. It will read the database and the messages table. It will call the OpenAI LLM model, get the response, again save into the database. Okay. But once you type exit, it will break the flow of your code. And this is how this chatbot works in LangGraph. Thank you so much for watching this video. Don't forget to like and hit subscribe button.